Okay, so in this video we're going to talk about using the ratio method to create scale drawings. This is in your packet, pages 9, 10, and 11, so please make sure you have those out. In this case it's talking about a ratio method, center of O, and a scale factor of 3. So when I look at my actual question, what you need to do for starters is to draw a line segment that connects O to A and extends it past A. You're also going to want to connect O to B, and extend that past B. You're also going to want to connect O through D and extend that past, and also O to C. So remember that with a dilation centered at O, everything is going to be coming from this point and being projected out further along the rays that I have shown here. So in this case, I'm going to poke at O. I'm going to open my compass up to A, and I'm going to make a little arc to show that I measured that. And then from A, I'm going to do another one, and then from there, I'm going to do a third one. And this point all the way up here is going to be my A prime. I'm going to do the exact same thing. So from A to B, I'm going to open up my compass to show that I measured that. Make a little arc right there. Then from there, I'm going to make another arc, and then I'm going to make a third arc. So in that case, this point here is going to be my B prime. I'm going to do the same thing for C. So I'm going to open up my compass to measure O to C. Then I'm going to do a second and a third. So in this case, this is going to be my C prime. And then I have one more point left to do, and that's for D. So I'm going to open up my compass from O to D. Then I'm going to make a second one, and I'm going to have to make a third one. So in this case, the third one is not crossing my line, so I want to extend that a little further. So I'm going to take this line, make it a little longer, and this point all the way up here is going to be my D prime. Now I'm simply going to connect A prime with B prime, B prime with C prime. I'm going to connect C prime with D prime, and I'm going to connect D prime with A prime. Now, it's a little hard to see, but in this case, this is my first, what looks to be like some form of a quadrilateral, A, B, C, D. And then if I wanted to highlight the larger one, that was with a scale factor of 3 through point O, then it goes to that one here. So in this case, we've created a similar figure because it was a dilation, and I could write that A, B, C, D is similar to A prime, C prime, D prime. So that's how I would do that with this point and a scale factor of 3. Notice everything is 3 times as big. So this piece right here, OA, compared to OA prime, would in fact be 3 times. This is 3 times this. Okay, let's take a look at the bottom of this page. It specifically says vocabulary, so a dilation. A dilation is a transformation that maintains shape but not size. A dilation is not a rigid motion. And the notation is typically capital D with a center and a scale factor. So for example, if I gave you this, D0, 3, that means that it would be a dilation centered at the origin with a scale factor of 3. So please make sure you write that down. Then we're going to go to the next page. So now we're going to page 10. So this is page 10, and it specifically says a compass and a straight edge. So I have my compass and my straight edge. And it says we're going to use the ratio method to create a scale drawing through point O and with a scale factor of 1/2. So already we should know that the scale factor is going to make my triangle, in fact, smaller. We're going to connect O to A. We're going to connect O to C. And we're also going to connect O to B. Now we want all of these to be half the distance. So from A to O, realize that in order to get half of this distance, we're going to do what's called the perpendicular bisector. So I'm going to open up to about 3/4 of the way. I'm going to make a big arc here. And then I'm going to poke at A and do the same thing. And once again, I'm going to do my dotted line because it's going to get a little tricky with all of these arcs and line segments in here. But this point right here is now my A prime. Then I'm going to do the same thing from O to C. You want to open up 3/4 of the way. So I'll go to 3/4 of the way about here. I'm going to make an arc. I'm going to poke at C, make the same arc. And you want them to cross. So this is where it gets a little tricky, but it's this arc, this intersection of arcs, and this intersection of arcs that I want to go through. Okay, and this is now going to be my C prime. Notice that OC prime is half the distance as it is from O to C. O to A prime is half the distance as it is from O to A, and then we're going to do the same thing for B. So notice we're going to have a lot of different arcs going on. But I'm going to poke at O, open up to about 3/4 of the way, make a big arc, poke at B, and I want to do it again. And I lucked out, I just made it. So I can connect it like that. And this is my actual B prime. And then I can connect these. So I'm going to connect B prime with C prime with A prime, and A prime with B prime. And now I have a new triangle right here that is smaller than the original. So I'm going to write triangle ABC is similar to triangle A prime, B prime, C prime. Okay, a little confusing with all the different arcs, but that's how you want to do it. You want to find the perpendicular bisector of AC, OA, and OB. And that would give me that. So the bottom half of this paper, it says what happens when the scale factor is less than 1 and greater than 0. We know that the object gets smaller. What happens when the scale factor is greater than 1? We know the object gets bigger. And what would happen if the scale factor was equal to 1? The object does not change size. It remains constant or the same as it was. Okay? That's pages 9 and 10. And now we're going to move on to 11. Okay. This next part here, it says, use your rule to determine the location of center O used for the following scale drawings. Determine if the scale factor would be less than 1 or greater than 1. So to work backwards, what I want to do is I want to connect A prime with A, and I want to extend it a little further. I also want to connect B prime with B, and I also want to connect C prime with C. Notice that all three of these are going to cross at this point, so we'll call that center O. This is like a vantage point in art. So when you're in art, you have something called a vantage point, or a point where everything looks as though it's reaching for. This is the center of dilation. Now, ABC, triangle ABC, is similar to triangle A prime, B prime, C prime, and it appears as though the triangle got bigger, because remember, this is my second one, and this green one here is my first one. So it appears as though r would be greater than 1. The scale factor would have to be larger than 1 because the triangle actually got bigger. And then the last one on the bottom, we're trying to find the center of dilation. So this one's going to get a little tricky, but I'm going to connect A with A prime. I'm going to connect B through B prime. I'm going to connect C through C prime. And you'll notice everything is starting to line up. D through D prime. And if I wanted to, I could do E with E prime. And everything is going through this point. So that's the center of my dilation. And again, this is the second pentagon. And this is the first one. So it appears as though the pentagon actually got smaller, so r must be less than 1. I also happen to know that r is going to be greater than 0, so it's going to be somewhere in between 0 and 1. I could also write that A, B, C, D, E is similar to A prime, B prime, C prime, D prime, E prime. Okay, that's page 11. Thanks, and I'll see you later.